Hi, I'm Tanish, and this video is about binomial theorem. A quick note: you're gonna have to know what combinations are to do binomial theorem. So if you have not already learned that, then you could check out the previous video I made on permutations and combinations to learn what it is. So let's start with what binomial theorem is. The binomial theorem gives us a way to expand this expression a plus b to the power of n, while n being a positive integer. So all the terms that you have to, when you use binomial theorem, have a combination in them. So, and the combination is always n choose a value. So it's n choose another value, n choose another value. And the value that you choose, it starts with 0. So the first term starts with 0. First term starts with 0. Second term starts with 1. All the way to the n plus 1 term. And the a is taken to the value, which is n minus the value here. So it'll be, the value here was 1, so it's n minus 1. The value here is 2, so it's n minus 2. And b is taken to the power of this value, the value that you choose from. This is 0, so it will be taken to the power of 0. This is 1, so it's taken to the power of 1. This is 2, so it's taken to the power of 2. Now let's try an example. So I have the expression 2x plus y taken to the power of 3. And now we gotta expand this. How do we expand it? We will use the binomial theorem for this example. Let's start. So the first term will be, nth value in this case is 3. So it'll be 3 choose 0, while 2x is taken to the power of 3, and well, y is taken to the power of 0. The 2x is considered Ra, and the y, which is considered Rb, is taken to the 2x, which is R8, is taken to the power of 3 minus 0, which is 3, and y is taken to the power of 0. And then our next term will be 3 choose 1. There'll be 2x taken to the power of 3 minus 1, which will be 2, and then y will be taken to the power of 1. And next term will be 3 choose 2, with the a term taken to the power of 3 minus 2, which will be 1, and y, which is the b term, which will be taken to the power of 2. Finally, we have 3 choose 3, with the a term taken to the power of 3 minus 3, which is 0, and then the b term taken to the power of 3. Now let's simplify this. So if 3 choose 0, anything choose 0 is going to be 1. So 3 choose 0 is going to be 1. And then it's times 2x to the power of 3. So it's 1 times, this will be 2x to the power of 3 will be 8x cubed. And then we have y to the power of 0, which is 1. And then we have 3 choose 1, which is 3. Anything choose 1 is going to be itself. 2x to the second power, which will be 4x squared, times y. And then 3 choose 2 is going to be 3 again. That'll be 2x to the power of 1 times y squared. And then we finally have 3 choose 3, which is 1. Then 2 times 2x to the power of 0, which is 1. And times y to the third power. So finally, it's equal to 8x cubed plus 12x squared y plus 6xy squared plus y cubed. It makes sense why the variables work. So since this is the first term, the x variable will be taken to the third power, right? When you normally expand it, the first term would be the highest x value. The y variable would be the lowest, right? So that kind of makes sense. If we normally expand this, this would have the highest degree of x, and this would have the highest degree of y, the last term, right? So that makes sense. But why does the combinations work? Well, if we pull out the Pascal's triangle, right? We use this row of the Pascal's triangle, the third degree row, because it's taken to the third power over here, right? Uh, and our coefficients are going to be 1, 3, 3, 1. If you don't know what the Pascal's triangle is, I haven't made a video on this, but it's essentially a way to expand it. It's not necessary to know this part, but it's just me proving how this method works, so you can skip ahead. But this is the coefficients in Pascal's triangle. And the reason the combinations are necessary is because if you look at this 3 choose 0 is going to be equal to 1, right? And the 3 choose 1 is equal to 3. The 3 choose 2 is equal to 3. And the 3 choose 3 is equal to 1. So we correctly have the 1, 3, 3 here for as you would have in the Pascal's triangle. So the combinations in this are meant to represent the Pascal's triangle when you're trying to expand it. You might be asking, why do we need to use binomial theorem? Wouldn't it be so much easier if we just expand the entire thing? It would be, like multiplying it out and expanding it, it would be much easier if you want to expand it, that is. So, but let's say that we want to find the fifth term in the expression 2x minus 3 to the power of 6. So if we look at the binomial theorem, right? And if we look over here, let's call this value r. So it'll always be n choose r. So anyway, if you look in the first term, r is equal to 0, right? And in the second term, r is equal to 1, and then so on. So if the first term r is equal to 0, then in the fifth term r will be 5 minus 1, which would be r is equal to 4, right? Now that we have r, we can figure out that it's gonna start with 6 choose 4, right? Since the r value we have here is 4. And now we gotta figure out what the a value, which in this case a is equal to 2x, and the b value, which is negative 3. You gotta find out what both of these terms are taken to the power of, right? So for the first, let's do the a value. A's power, the power over here, in relation is just n minus r. It'll be 2x n minus r, which would be 6 minus 4, and that's 2. And then we have b. What is b taken to the power of? B is basically taken to the power of r, right? This is taken to the power of r. So it will be negative 3 taken to the power of 4, which is what r is in this case. So if we solve this out, 6 choose 4 is 15, and 2x squared is 4x squared, and then negative 3 is to the 4th power is 81. If you multiply it out, it'll be 4,860 x squared. So this is the fifth term of this expansion. Let's try a trickier problem. Find the coefficient of the x squared term in the expansion of 3x squared plus 2 over x all taken to the power of 10. Alright, we're trying to look for the x squared term. And if you tell me, Tanish, since it's taken to the second power, shouldn't we look for the second term? Well, that probably won't work in this case, because if you look at the a value, which in this case is 3x squared, and the b value, which is 2 over x, 2 over x, right? So that's essentially x to the negative 1, 2 times x to the negative 1. Well, when you expand this out, you have to take this to a certain power, and you have to take this to another power and multiply them, right? So you probably won't be able to attain x squared. So we have to find the power you take this to and find the power you take this to multiply it and attain the x squared term. So first we're gonna have to figure out what term that is so that we expand it. So that we can expand it, we have to figure out what term it is. So since we're focusing on fixating the variable's power, right? We're trying to find what to take the variables to the power of to attain x squared. And since we're doing that, we don't need to worry about the coefficients yet. So we're going to disregard the coefficients and consider it as x squared and x to the negative 1 power. All right, and just make the binomial expression without the coefficients. So it's going to be 10 choose, and I'm gonna call this variable r times x squared taken to a power, and then x to the negative 1 taken to a power. Now this x squared is taken to this 10 minus r, and this x to the negative 1 is taken to the power of r. So we have to make this equal to the x squared term. Now that we know this, since we're not focusing on the coefficients, all this combination will give us a coefficient and not a variable, so we don't need it. All we needed was this, and I just used the combination to help you show you what to take to this power. And now let's solve. I'm gonna simplify this entire mess, so it's gonna be x 20 minus 2r times is going to be x to the negative r, and that's going to be equal to x squared. To solve this, you're going to have to use some exponent rules. So since we're multiplying these two things, then we're basically going to add the exponents. So it's going to be 20 x to the power of 20 minus 3r, which is equal to x squared. We have the base as the same, and that's x. All we need is the exponents to be the same. So for that, it'll be 20 minus 3r is equal to 2, and that means 3r is equal to 18. R will be 6. We know r is 6 now, and that can help us because we can finally do the expansion. Now we consider the coefficient. I'm going to do the entire expansion with the variable as well, because I'll show you that it's correct. So it's 10x, 10 choose 6, because r is 6, of 3x squared. Then 10 minus 6 was 4 times, times 2 to the power of 2 over x taken to the power of 6. 10 to 6 is 210 times 3 to the power of 4 is 81 squared. 81 squared. 81 times x to the 8th power. And then this will be 2 to the 6th power, which is, I think that's 64. And over x to the 6. If we multiply this out, it'll be 210 times 81 times 64, which is a very large number. 108640. And then if you multiply x to the power of 8 times x to the power of negative 6, then we should get x to the power of 2. And like that, we found the x squared term, which happens to be the sixth term in the entire expansion. And the coefficient of this term is 1,088,640.